Welcome to Three Devs and a Maybe. Now introducing your show hosts, Michael Budd, Fraser Hart, Lewis Gaines, and Ed Mann.
Hello and welcome to another episode of Three Devs and a Maybe. My name's Ed Mann, and today we're joined by Liam McLennan. How you doing, Liam?
Very well, thank you.
Brilliant. Yeah, thanks for taking the time to come on the show, man. I really appreciate it. How did you get into programming?
So for me, when I was in high school, I focused very much on the maths and physics and chemistry and all that kind of thing, and really got burnt out on doing all the mathematics. So pretty much my only rule when I went to university and was looking for something to study was I wanted to find something that wouldn't have a high mathematical content. And also about the same time, there was a lot of media about how great IT was going to be and all the jobs you could get and so on. And so I enrolled in IT not really knowing anything about it, and was just very lucky that it turned out to be something that I really enjoyed. By the time I graduated 3 years later, the industry had completely tanked, and my class of 800 graduated, and pretty well nobody got a job. So that the second part of it didn't work out quite so well, and it was a bit of a slow start. But you know, it's worked out in the end, so I have no complaints.
Because it's interesting, actually, you say, so you come from a math background then, and then you wanted to move into computing. Did you find that there was any similarities? And obviously now with functional programming, everyone's talking about the math side of things and category theory. Can you see the similarities in there?
At the time, I couldn't. So for me, when I was studying, programming was more of an art, and I thought I was winning if I could get the program to compile. It probably took me a good 10, maybe 15 years to really come full circle, and firstly to fall back in love with mathematics just purely for its own sake. And eventually I went back to university and did some postgrad math stuff, but also to realize that programming is nothing but applied mathematics, and you can choose to look at it that way, or you can choose to not look at it that way and still be very successful as a programmer. But you know, it's binary, it's calculation, it's Boolean algebra, it's just layer upon layer of mathematics, and I guess that's, you know, went hand in hand really with me starting to look more and more into functional programming over the last 5 years or so.
Did you find then that your perspective on it changed then when you started to really realise that it was just applied mathematics, or did you kind of look at it in a similar way to, you know, just getting it to compile?
No, absolutely changed my perspective. In many ways, realising that programming is applied mathematics doesn't practically help you as a programmer, but it helps philosophically in a way to think more about correctness and what that means. I did a presentation recently where one of the questions I asked the audience was to explain to me what a type is. And it's amazing how a room full of 50 people can't give you a coherent definition of what a type is in programming. And because we use these things, but we don't necessarily stop and think about why they exist, or the sort of higher level view of what's really going on. We can get very focused on trying to solve our particular problems and this or that syntax of whatever programming language you're working with at the time, without thinking about the broader questions of, you know, how do we structure programs to make them simple and correct. And that simplicity for me has been a huge focus.
Because it's interesting, because you actually did a good blog post on the fact of, you know, you're falling back in love with mathematics. And I got to say, I'll put it in the show notes, but your blog is a really great resource.
Thanks. I that was one that came to me in the shower, and I thought, oh, this is a great idea, and I can articulate the way that I feel about these things. And then I wrote it out and read back over it, and it didn't really seem to hit the mark for me. It's a very complicated thing to articulate, you know, the joy of mathematics and science, and why I love learning those things just like purely for their own sake, even if there's no application at all.
You know, so you say you graduated and then you didn't find, no one found a job. But one of the things you have done since then is a lot of consulting. How did you find your experience consulting?
It was amazing. I loved it. At least I did the second time around. So I had 2 stints in consulting. The first time I lasted about 12 months, and really found the whole experience entirely unsatisfying, because what I wanted to do was, someone to give me a hard problem and sit down and solve it, and we'd all work together and apply common sense and create a great solution and then move on to the next thing. And my experience was more that day-to-day consulting can feel like a series of engagements working for people who don't know what they're doing. And I later realized that's almost by definition, because if they knew how to do it, then they wouldn't need the consultant. So every gig turns out that way. The second time, I probably had about a break for, 3 or 4 years, where I went and did some startups and various other things. When I came back to consulting the second time around, I took a much more holistic view of the endeavor. And the approach was more that the goal is to get to a successful outcome. And the fact that your customer is very often their own worst enemy is just another one of the challenges you face. So you can't restrict the challenge to the technical domain. In the company that I was working for, we had a saying, which was that it's always a people problem. And I found that to be true. So if you were focused purely on the technical problem, then you were always going to, maybe you'd write some nice code, but you were never going to have a successful outcome for your project, because the real work was understanding the different people involved and what they were trying to achieve, and looking for the strategy that would work in that particular context. So that was another thing I really learned, was that if you're working in the same place for a long time, you can find a way of being successful and sort of draw a line in the sand and say that's it. I've worked out this software development thing. This is the steps you take to be successful. But as a consultant, because you move quickly through lots of projects, if you do that, you take that playbook, bring it to the next project, and fall completely flat on your face. Because what you have to realize is that every approach is relevant within a particular context. You change the problem, you change the people, and you have to change the solution as well. And that's why we were never dogmatic about particular agile methodologies or anything like that, because all of that stuff is just a starting point. You take your lessons that you've learned in the past and you carry them with you, but you also have to understand that every situation and every set of people is going to have a unique path to the best possible outcome.
Absolutely. And I think that's so true, though, that it's mainly about emotional intelligence and dealing with people. And it mainly is a people problem. And I'm just wondering, kind of like, what does a consultant's job entail then? For you, what did it actually entail?
Every project is different, but normally you would start by trying to understand what the situation is, what the particular customer is struggling with, and trying to find the overlap between the things that you and your team can do and the particular problem that they have. Put a bit of structure around that, do a little bit of planning, and then bring in a team of really the best people you can find. Usually a very talented group, I think, and I found that that's a pretty good recipe for getting things done. But it was, I guess the reason why I liked it so much is because of the compression that you get in being able to move so quickly between projects and clients and teams. So the things that might otherwise take a decade to learn, you might be able to learn in 1 year, which is why I've always recommended to people that they give the consulting game a shot at some point, just as an opportunity to learn really quickly and hopefully work with some really smart people.
No, because that's so true, because you are changing stacks, changing ideas, changing people, learning different personalities. And I mean, that must be one of the interesting ones, dealing with the different personalities, because obviously you come in and, people, and the whole idea of the game is that, maybe they don't understand something as well as you do, or you're trying to come in and, maybe apply some things to their domain or something. And maybe some people don't like it and you have to kind of work with different people in different ways. I'm just wondering kind of like, how did you go about that? It's not only the tech side, it is the people side as well.
I had to learn some pretty hard lessons. So one of the things that I hopefully or fortunately learnt fairly quickly was just the importance of tact. And this is a skill that so many developers lack, But when you're coming in from the outside into somebody else's organization, you need to learn to tread carefully, but still be able to get what you want. Another thing that I learned was that the carrot works a lot better than the stick most times. So we go with a very gentle approach, but you do also need a little bit of the stick sometimes. There are times when you have to stand your ground as well, and knowing when to apply which strategy is an art form, and it requires a bit of experience, I think, to learn how to navigate those kind of situations.
Did you find that it was mainly 50-50? Bringing tech in is great and knowing all that side, but actually being able to apply it based on the people and the personalities at that company was, another struggle.
Yeah, so I guess really getting to a successful outcome, it's always the organizational and the people set of skills that ultimately will be the difference between success or failure. But I say that knowing that for me and my team, we already had the technical stuff really well nailed down, by going through a lot of projects and getting to a system that worked really well. So with that as a baseline, then the difference between, winning and losing is all about how you can navigate the organization. Now, if you didn't have that sort of fundamental baseline of technical capability, then that absolutely would be a problem. But what we found was, as hard as it is to find good people who can do a great job of writing software, it's still an order of magnitude easier than finding the real delivery people who can ship projects under challenging circumstances.
Did you find then a lot of it as well was to do with educating them? Also for the fact of, when you leave that project and they need to maybe support it or something like that, understanding where you're coming from and what technology stack you used and the problem solution that you made?
Yeah, so we used to talk about the idea of bringing the customer's team along with you in the decision-making process. So one thing you learn is that there are times when you have to make a decision, and regardless of what decision you make, somebody will always be able to look back in hindsight and say that was the wrong thing to do. So the solution to that as a consultant is that you don't make those decisions by yourself. You train the customer and the customer's team, and you say, here are the set of options and the strengths and weaknesses of each approach. We think you should do whatever, and they will look at it 9 times out of 10. They will say, that makes a lot of sense. I agree with you. And that decision that they would otherwise have complained about later, they now can't because it's their decision.
So say doing it together also makes it, a partnership, for the actual creation of it. And it's going to create a better value because they know things that you don't and you know things that they don't. And as you say, it is a partnership to work on the best solution at that time with the context with the information that you know.
Yeah, and I guess also you don't want to set up like a class system where the consultants are coming in to do all the fun jobs and the customers team's left to support it when they all leave. And it's very important, I think, to say we're all one team and we're working together on solving the problem. You do still have that problem also that whatever it is that consultants create, ultimately they won't be the ones left looking after it. So that's another reason why it's very important to involve the team who's going to have the longer responsibility. And it's also part of why I ended up getting out of consulting, was because I wanted the opportunity to actually take responsibility for something on a longer term and create something that I could really associate myself with and take ownership and feel a bit of pride in something over a longer period of time. And the problem with consulting is you typically leave a project right about the time that it starts to deliver value, because then your work's done and you move on to the next thing. And after a while, I didn't want to do that anymore.
I can imagine that, yeah, because you've almost built it up from nothing and then you've left and you never get to see and reap the rewards of actually seeing something that you've built, and maybe the decisions that you made were wrong, but you learn from those and stuff, but you've already gone off to another project.
Yeah, absolutely. Yeah, you put your heart into something and then never quite get to see it be born.
One thing you have mentioned actually already was the fact, you kind of forayed a bit into the functional programming side of things, and one of them is F#, and actually you've made a Pluralsight course on F# fundamentals. What drew you then into the functional programming world?
Well, I have a theory that the more experienced and the better people become as programmers, the more aware they become of their own limitations. I think I've observed that in a number of other people, and it's certainly been my experience as well. The thing that drew me into functional programming was ultimately an acknowledgement of my own limitations, particularly in terms of being able to deal with complexity in software. When it was no longer sufficient for me to say, the program compiles and it looks like it works, therefore I'm a success. When I started to care more about making something that was, closer to being truly correct, and then you realize the enormity of that as a problem. If we're talking about an object-oriented system and we have 1,000 little objects flying around, all with mutable data and their own rules about how that data can change, and they're all connected to each other in complicated ways that can change, the complexity of that system is just, there isn't a number big enough to describe that. And when you say, okay, like I want to know that this thing is going to work properly today and forever, I need to understand what's happening in that system. You can't. It's too complicated. You can fiddle with it until it appears to look like it's working, which is how it's often done. But to truly reason about what's happening at any point in time is very complicated. The function, on the other hand, like forget about functional programming, but just think about a function. A thing goes in and something comes out. It's very simple. And then when you want to join lots of little functions together to make a larger function, that property still holds, that even for that larger aggregated function, it's still just one value in and one value out. So we're able to take a lot of complexity and hide it inside that kind of function. And so for somebody who's trying to create software that's simple and easy to reason about and doesn't have a lot of moving parts to kind of keep in your head as you're working and thinking about how your program is going to execute, I found functional programming to be really a great relief, just in terms of the way that you take a problem and break it down, and something that's very complicated as a big thing that we're trying to achieve becomes just a simple composition of lots of simple little pieces that do just one little thing at a time.
With that then, obviously I mentioned the Pluralsight course, the F# one. So what drew you then to F#? Like, was it the fact that you're on the .NET stack?
Well, I really actually tried them all. I think what drew me to F# was that I liked it the most. So I'd also done some work with Haskell and Erlang and Clojure and more recently a little bit of Scala. And I try to understand whatever's out there. I think that in some ways I really liked the Lisp and the ML style of languages for functional programming because they have certain properties that's well suited to it. So Lisp really appealed to me in that sort of the simplicity of it. Obviously, I was on a bit of a simplicity kick. So the idea of having a language where the code that you write is expressed in a data structure of the programming language itself, I thought was really neat. But just in practice, when I tried to use it, I struggled a little bit. In some ways, I think I struggled a little bit with the syntax, and also having come a little bit from the mathematical side, I was really looking for something with some static typing. Also, I think that's partly related to that idea of understanding your limitations and finding tools that support you as a programmer. So if I can utilize a static type system that someone very clever has created to help me not create errors, then that's something that's quite appealing to me. The ML style languages like Haskell and F#, they just have a syntax that fits in really nicely with functional programming. So they've sort of done away with some of the parenthesis and that allows them to do the automatic currying and partial application and lots of sort of neat little tricks that just turn out to make life easier when you're working with functions. The other thing, I suppose, is that F# is being a .NET language. It comes with a really good runtime. It's like very much the equivalent of the JVM, and it also comes with a nice standard library that has most of the things that you might want to do, and access to an ecosystem of packages that have been created by the .NET community. So from the sort of practical perspective of sitting down to create a program that's actually going to do something and that I can be commercially viable with, working with one of those languages that is already part of an existing ecosystem, like F# with .NET and Clojure with the JVM, I think it's really very helpful, as a commercial programmer trying to get things done.
Going back to your consulting experience, the stacks that you had to use there, did you always employ the stack you wanted? You brought in the code as well as the stack that you wanted to use, or was it chosen for you based on the actual company that you were at?
So philosophically, I'm very much of the opinion that a good programmer is a good programmer, and the specific technology kind of is much less important. In terms of the consulting company that I was in, it's interesting because the team were very good and very kind of cutting edge in their own sort of way as technologists. But when it came to the technology selection for our projects, we were actually extremely conservative. Not so much by choice, but more by virtue of the fact that we were very conscious of creating something that we would then be handing over to somebody else to support. And also, as a consultant, there's a feeling that you're not in a position to take on a lot of risk, because you start a project and you make a commitment to get a certain thing done, and so you have to have faith in this existing or established set of tooling and know pretty much how you're going to get from where you are to the end of the project. If you're in an internal team, you might have a little bit more leeway to insert a bit of risk into the process and say, we're going to try this new thing and maybe it'll be twice as good, but maybe it won't work at all. And maybe that's a calculated gamble you can take. But as a consultant, we generally weren't in a position to do that kind of thing. So we tended to use very standard kind of technology stack in the Microsoft ecosystem. One of the pieces of professional development work that I did when I was there was to investigate the practicality of using F# on consulting projects, and I actually wrote about that on my blog as well. The conclusion that I came to was that for anything remotely complicated at all, F# would be not only viable but an excellent choice. There was really nothing stopping us from a technical perspective. It was more about what the customer was prepared to take on and maintain.
I think that's it, isn't it? Yeah, because of the fact of being on the CLR, similar to the JVM, the fact that it runs, you don't need a different stack. It is just the fact that the code's different. But obviously, when you're giving it over to them, if you're just saying, I've written this in F#, and they're like, well, we need to find someone who can actually understand that's the hard bit. Being able to apply maybe into your C# and other languages that you decided to use on the CLR. How did you use that functional paradigm that you had in your day-to-day code?
Yeah, absolutely. When you start doing functional programming and working with F# or Haskell or any of those things, it changes the way that you work in the less sort of functional first programming languages like the C# for sure and JavaScript as well. So I guess the simplest way to say it would be that I've moved towards using more pure functions in my programs. So I know that you've had Scott on before who explained what pure functions are. So for me, as a mathematician, in maths, they're just called functions. It's a thing where if you put a value in, you always get the same value out. That's a pure function. And if you write your C# or Java or JavaScript using pure functions where you can, a whole lot of things get a lot easier. Like testing's an obvious one. Testing a pure function is the simplest possible thing, because you just give it some values and see what it returns, and either that matches your expectations or it doesn't. So you tend to arrive at a sort of a layered system where all of the I/O and the networking and the integration with other systems happens at the periphery of your application, and then you take all those values that you get and you pass them into a the core of your application, which is more pure functions. And this is not dissimilar to the ports and adapters and onion architecture and things that other people have come up with in a completely different context that's not at all about functional programming. But it's interesting to see that ultimately people arrive at the same good idea regardless of which way they came at it.
Within your kind of your remit of what you're using then, it was primarily like the C Sharps, if you're saying about the Microsoft stack that you were using?
Yeah, C Sharp and Microsoft's SQL Server. I guess towards the end, JavaScript became a much larger part of it as well. So we were doing a lot of projects with AngularJS and then somewhat less with React and things like that as well.
Yeah, because I was going to actually kind of just a little tangent there that you were discussing in your blog, using Redux and kind of using Redux within React world and then also maybe applying that into Angular. And I was just wondering kind of like, what was your experience with doing that?
So initially my experience was sort of euphoric. It was, yes, you absolutely can use Redux in Angular. But then I thought about it a little bit more, and I thought, in the context of a team of people, and particularly a team of people with Angular experience, the only way that you can make it work is to put a very rigid set of rules around how you build your Angular program to be able to get the benefits of that kind of design. And the thing about Angular is that it's at the opposite end of the spectrum in many ways. It's the framework for people who don't want that rigid constraint. They just want to be able to get in and do whatever they like. Yeah. I've definitely preferred to use React. So I also have a Pluralsight course on React. And it's because for anyone, I think, with that functional mindset, React is very much of that kind of school. Even down to a component in React is very often just a function. So if you appreciate that kind of design and structure, then I think that you're going to tend to gravitate towards React. Of those two, of course, there are many other choices as well. I think that Angular is fine. It's okay. I've worked with it, and I also think that React is not perfect at all. So I'm sort of not really in love with any of the frameworks, but I do enjoy working with React, and I think that if you do it well, you can end up with something that's really quite neat and maintainable.
Yeah, absolutely. And you mentioned there another Pluralsight course, and I was just wondering kind of what drew you then to doing the Pluralsight courses? Was it kind of your learning and teachings from your consulting?
It seems funny now, but they contacted me probably 6 years ago because they didn't have a JavaScript course, and they were looking for somebody to do a JavaScript course. And that seems strange now to anyone who's been into Pluralsight, because they probably have 200 courses on JavaScript, but mine was the first. So I got into it because they asked, and it seemed like an interesting thing to do. I like the idea of teaching and learning via teaching, and I enjoyed doing them. So I kept it up over the years. I think I've got 5 on there now.
Yeah, no, you've definitely done quite a few. Have you got any other in the pipeline?
I've thought about it a few times. I thought I might do just a really short one about promises in JavaScript, just because everywhere I look, I see people abusing them horribly, and it's something that you really do need to understand these days to work with JavaScript. But it is very confusing, and it's hard to necessarily know how to use them properly. So that's crossed my mind, but I just don't think I have the time at the moment.
It must be quite a lot of investment in time to set up and actually, prepare the course and then record the course and all these kind of facets to it.
The F# one took me more than a year. that was a real labor of love. In the end, I was very happy with how it came out. It's my favorite of the ones that I've done. But yeah, for me at least, they're a lot of work. I know some other people get through them much faster, but yeah, it's a big commitment to take on.
Absolutely, and trying to work it into your day job as well. If you're doing it full time, I can understand that you're able to keep in that context all the time. But for you, it must be kind of weekends and evenings and stuff like that.
Yeah, and it's hard to find somewhere to record because you obviously need somewhere that's quiet. living in Australia, we've got a lot of wildlife, and I used to get complaints from the editor about the crickets and the birds and all this kind of thing. So I used to get up early and go into the office and set up my microphone before people arrived and do a few hours before work. It was the best way I could find.
It's crazy. It's all these things you don't think are going to be the problem, but then they turn out to be the ones. It's like, no, the content's great, but it's the background noise that we can't handle.
It was that, and then kids as well, so the same sort of problem.
Yeah. But one of the actual examples that you did on that F# course was the Nokia Ringtone Composer application. And I got to say, it is a great project, and it's really interesting. And I'm just wondering kind of what drew you to creating this emulator? Well,
I used to own one of those 1990s Nokia phones, and I guess I have a little bit of nostalgia for them.
And obviously now with actually, the actual phone being released again, the 3310, it kind of brought it all back.
I didn't know anything about that. I heard about that on your podcast, actually. Maybe I should go grab one of those. At least I could test my emulator and see how faithful it is. Probably not very at all, but that's okay. I guess I needed an example for the course. You want something that's going to be a good teaching aid, where you can build up something over the course in such a way that each individual step makes sense and is at the right level for the student at that particular point in time. And that really narrows down the set of possible projects that you can take on. But the thing about the composer is that there are so many different little parts of it that can be used to demonstrate different features of F#. So for people who aren't as familiar with the 3310 as you and I, it used to have an application called Composer, which had its own syntax in which you could compose ringtones. So to create an emulator for the 3310 Composer, one of the things that you need to do is parse out that Nokia syntax. You also need to generate audio. You need to create sound files. And there was a little bit of a web component as well, because I made just like a little 3310 front end just to kind of make it a little bit fancier. So those were all good things that I could use in the course to demonstrate features of the language.
The whole project itself is a great way of being able to delve into different kind of aspects and stuff. Parsing, because one of the things you did, especially in the blog post that I read, was you used like a parser combinator, and you've used fparsec to parse the actual ringtone syntax. And I'm just wondering, kind of, how was your experience using that? Have you used it in the past, using something like a parser combinator, or was this your first kind of look into that?
I can't say for sure. I think it might have been my first attempt in earnest. And what I can say is that in probably 25 years of programming, writing the parser for that particular program is the most fun I have ever had. Parser combinators are just brilliant. It's so much fun. They make you feel smarter than you are, and it's just that thing of lots of simple little pieces that you just gradually glue them together, and all of a sudden you've got this amazing thing. So yeah, lots of fun.
And actually, so for the audience, what actually is then a parser combinator?
Okay, so the parser combinator is a library, really. So I guess fparsec is a parser combinator library. A parser is a function that converts a piece of text into some kind of data structure. So, for example, the simplest parser, you might have a parser that can read the character A. That could be a parser. A parser combinator then is a function that can take multiple parsers and combine them together in some way to create a larger parser. So we might have individual parsers for each letter of the alphabet, and then we might use a combinator that is like an OR to connect them together. So that could parse, an A or a B or a C, or so on through the alphabet, and it creates a new parser that can parse any character. And there's many of these different kinds of combinators. Some which do, I guess, they connect parsers together in all kinds of different ways, and thus you're able to build up your overall parser for the entire string of text that you want to parse. But even at the very top level, the parser is still doing the same thing. It's reading that entire composition in the Nokia 3310 syntax and converting it into a data structure that we can then give to our program to convert that into audio.
Brilliant. Yeah. And you say, like, so once we've got this syntax and we've passed it, then it's actually starting to try and generate the actual signals and the actual tones. And that was something that I'd never done before. What actually then is a signal generator? Because you had a really great article on kind of, your foray into that.
So at least to me, the signal generator is just something that can create a pure tone. And I went into this without any background at all, so it was sort of down to reading Wikipedia articles and so forth, and that was half of the fun. Because the first thing you need to do is understand what actually is sound, and sound is just changes in air pressure. So if you were to take the weather report and say, today is low pressure and tomorrow's high pressure, if you were to get that data set over 10 years and compress it into 10 seconds, then you would have audio of what the weather sounds like in your particular area. So for a signal generator, we wanted to generate a pure tone, which is just the gradual change from low pressure to high pressure at a particular frequency. And it just so happens that when you have a gradual alternation between two extremes, mathematically we can model that as a sine wave or a cosine wave. So to create my signal generator, effectively what I did was start with the sine function, stretch it vertically and squash it horizontally to get the frequency that I needed for the composition at that particular point, and then just read the values off the sine wave. And that's how you create your audio.
Digitizing it and actually put it into the WAV format. How did you go about that?
So, I started with a little bit of Googling to work out what the WAV format actually is. And again, this was something very new to me. I haven't done a lot of work at that kind of low level of writing file formats. It reminded me very much of the way that network protocols work, which is that for a given file type, the first part of the file is a header that contains metadata that describes the rest of the file. So in the case of the PCM wave audio standard, firstly it identifies that that's the type of file it is, and then it has information about the way that the audio is encoded. So things like what is the sample rate of that particular piece of audio, and the sample rate means how many times in 1 second do we measure the magnitude, or rather the amplitude of the signal. So that's in that metadata header. There's also information about the bit depth, which means every time we take a sample, how many bits do we use to record that? And between those two things, that's pretty much what defines the quality of your audio signal. Then there's information about how large the data segment is, so that somebody creating a program to read your file knows how far they have to read in memory. And then the actual audio data is just binary, values representing the amplitude of the wave. For digital audio, that's how the analog signal is encoded digitally. We look at the wave and we just take a measurement at regular intervals and just store those numbers. In the case of CD audio, which is what I used for my composer, we measure the signal 44,100 times every second, and for each of those measurements we store a 16-bit number representing the amplitude of the signal at that point.
It's so interesting. And have you actually thought of any other, because now obviously you've kind of done some work into this and learning how to create these tones and things. Have you thought of any other projects that can maybe foray out into that kind of uses this same kind of technologies?
Yeah, I did actually. I got some way on a project that was sort of the same thing but in reverse. So the challenge that I wanted to solve was to build a program that could take an audio file and say an audio file of a car passing and tell you how fast the car is going, which is Doppler speed detection. It's not it's not dissimilar to the way that the radar guns work. But you could certainly do that with very much the same technology. It's just going in the opposite direction, where the Nokia Composer program is generating a particular piece of audio from a source. Now what I want to do is take the audio and kind of go back to the source. And it combined, some of my different interests. So the first thing you need to do is understand the pitch of the audio as the car is approaching, and then as it's passed and is receding. And the way that you take a piece of audio and extract a pitch from it is using Fourier transformations. So you get into some pretty amazing mathematics. So that was a lot of fun to get into the research. Yeah, and very much like the Composer, you could cheat, and you could grab a library and you could say, here's a piece of audio, tell me what the frequency is. That would certainly be possible. But for me, the fun thing was, that's what you do at work when you're on the clock and somebody's paying you to be valuable. But when it's on your own time and you're trying to learn, it's fun to just not use the libraries, but just go back to first principles and really understand what's going on and just get your hands dirty on solving the problem yourself. So yeah, for me, that's been really the enjoyable part of playing with these projects.
Is there a certain reason for this? Are you hoping then maybe to put this into another Pluralsight course, or was this mainly just for kind of scratching that itch of seeing if it was possible? Yeah,
it just occurred to me that you should be able to do that, and it turns out you can.
Obviously, the emulator was written in F#, and is all the other project that you were talking about, is that F# too? Kind of using the functional approach?
Yeah, I did write it in F#. What I actually was trying to do was I was looking for a challenge to run a programming competition, kind of like what Google and Facebook do. When I was in the consulting business, we were looking for ways to make our hiring more interesting. So I thought, well, we'll run one of those coding competitions and have some prize money and all that. And so I thought, well, maybe this would make a good sort of final challenge to really separate people out. But I thought, I can't issue a challenge unless I've demonstrated that you can actually do it. Plus it's fun. So I sat down to do it, and eventually I abandoned it as an idea for a programming competition, just because the first thing you have to do is take an audio file and extract the data out. And too much of people's time would just have gone into that problem, which is not interesting in any way. It's just tedious. So that's why I didn't make a very good programming competition problem. But as a spare time project, it was great.
And then actually from there, then another project that you actually talk a lot about on your blog is your Blackstar CMS project. And I'm just wondering, kind of like, what is the history behind that?
It came out of my experience as a consultant. I observed that we did a lot of projects where we would build an application, and the customer would say to us, there's some public-facing component of this custom application where I want to be able to change some content, or my marketing department wants to have control over the text on the buttons and the paragraph of text and so on. And what we ended up doing inevitably was building our own very basic and very limited CMS into these custom applications to give them the ability to change some content here and there. So the idea was to create a server or an application that would serve that need of custom applications that just want to have some very basic editable content, but in a CMS system that's focused on that problem and very simple to use. So it's a headless CMS, meaning that it serves its content via an API. It doesn't serve web pages. So as the author of an application, you just define the particular regions where you want editable content to go, and then at runtime it pulls those values out of Blackstar. That was the idea. That and combined with the fact that there are existing systems that do the same thing, but they're inevitably hosted offerings. They're all software as a service, which can be great, but I personally am very cautious about taking on runtime dependencies that are hosted by somebody else.
Especially if you're in a consulting and you're going to give it to someone else.
Yeah. Now I don't just have to worry about my system going down. I also have to worry about somebody else's system going down. So yeah, I 2015 was the year that I went back to university. That's what I did that year. And then in 2016, I sort of very specifically set out and said, this year I'm going to create a software product. I'm going to do it 100% and see if I can really make it work. Because I'd had some sort of earlier attempts that I hadn't maybe put as much effort into as you really need to if you want to get something off the ground. So yeah, 2016 was Blackstar CMS, and I was reasonably happy with the way it turned out as a product. I didn't really find a market for it, so at this point it's sort of pretty well dead. But maybe I'll use it for something in the future. I don't know.
That's it, and it's always a great learning curve. Like any project that you make, and especially if you put enough time in and you're trying to do it to completion, it's one of those things as developers I think we're very good at. We're good at starting projects, but finishing them, it's that last portion is probably our downfall.
I think that's why I feel okay about it, is that this time I did finish it. I did it 100%, and I did learn a lot. I learned that I'm a terrible graphic designer. I learned a lot about the marketing and all the tools that are available there these days. So that was all useful information that's helping me a lot now with the things that I'm working on.
You say so you out of the consulting game now, and you kind of moved on. I think you said in the blog post you said you're in a new startup. I'm just wondering, kind of how is that going, and going back into that world of a one product.
Yeah, it's been great. I'm really enjoying it. I've got my own little team, and it's the same team consistently working on the same problems, and with a longer time horizon, more sort of personal investment in the way that things go. I'm really having a great time. I just don't have enough hours in the day is the current problem.
Oh, that's brilliant. Well, I'd say thank you so much, Liam, for taking the time to come on the show. It was really interesting, going into all these different aspects, and it would be great to have you back on again. Maybe we can kind of go into more depth. I know we kind of touched on a couple of areas here.
No problem. Thanks for having me. It was a lot of fun.
Audience, well, it's been another great episode, and we'll speak to you again next week. Goodbye.
You've been listening to 3 Devs and a Maybe. You can contact us at contact@3devsandamaybe.com. Or follow us on Twitter at 3 Devs and a Maybe.